Hello, everyone. Thank you for watching. My name is Daphne, and I'm a sixth grade math teacher. Specifically, I teach special ed in an ICT classroom. This is my first year ever teaching Eureka Squared, but I have been teaching with Eureka, the original one, since 2017. And I feel really confident with using Eureka. I realized that the biggest thing with that curriculum is they provide you with a lot of examples, they provide you with a lot of different exercises, and by no means is it meant for it to be taught all of the examples at one point and then for the students to do all of the exercises. Like they give you a varying amount of like lower level questions with higher level questions, and I really enjoyed that. So you kind of get to pick and choose, and then every year kind of changes a little bit depending on the needs of your class. So I fell into a rhythm of planning lessons, creating my Google Slides, and then now suddenly my school is transitioning to Eureka Squared. So I wanted to show you kind of my thought process behind everything. And the main inspiration for making this video is that I have seen nothing but kind of bad reviews about Eureka Squared and just how labor intensive it is and how many materials are needed. So they're not wrong. No, I'm just kidding. But I don't know. I guess it's just that this is my first time ever using it. So it is kind of a challenge. And I haven't even taught it yet because we're still in summer. But I've developed a little bit of a rhythm of like what I look at first and how I plan it out. So I'm going to show you. The lesson that I'll be using is Module 1, Lesson 23. And again, this is the sixth grade math. So the first thing I do is when I go to Great Minds, the overview, should be able to see the objective here. I read the objective, and then immediately I go to classwork practice and exit ticket. I download all three of these and I print them out. What I've been doing is I've been keeping a binder that I have here. I've planned about 6 lessons so far. My math team and we've split up by topic. That's why I'm not starting with lesson 1. So I've already done lesson topic C, and I print out the classwork practice and exit ticket without the sample solutions, and I literally do all the problems myself. I have found that if I don't do the problems that I'm going to assign my students, I don't know how to help them. And I don't want to be in that situation where I either have a small group or I have a group call me because they need help and I don't know how to help them. I don't know the problem. I want to be prepared as much as I can. So it is a little bit time consuming, but I think it's necessary if you want to be prepared to teach something that your students are going to actually learn. So was that feisty? Maybe. In addition, I'm really looking at the exit ticket. The exit ticket for me is what guides my lesson because at the end, this is how I'm assessing my students. And so in this particular lesson, lesson 23, I realized they're being asked to draw a double number line and they need to be able to answer questions pertaining to percent. So let me quickly go over to that exit ticket. So you can see right here. Now, this is where I kind of changed it up. By this point, they should know how to do a double number line because that is taught in topic B. So I had to look back and make sure, what do my students already know? Because I'm not creating those lessons, another teacher is. They should already know how to complete a double number line. But the majority of this lesson uses tape diagrams. And I feel like you can use them interchangeably. So I am going to tell my students to just use a diagram. If they choose a double number line, perfect. If they choose a tape diagram, perfect. But I love offering my students that choice. So then, after I know what the lesson is about and I know what the lesson's assessment will be assessing, then that's when I start reading through the actual part of the lesson. So this lesson is a little different, and I thought it was very interesting. It starts off with kind of a story or like some facts about ancient Rome. And I really like this. I think it's engaging and it gives students an opportunity to discuss things that usually aren't discussed in the context of a math classroom. So it talks about how 2,000 years ago, the Roman Empire, how they collected taxes from their citizens. And then it goes into kind of like a prompt for students to determine what would be a fair tax for these three types of citizens. So this is what I created. In the introduction, I have here exactly what was put in the lesson by Eureka Squared. And I highlighted or I bolded those words tax, tax, tax. I want students to know that that's what we're talking about, tax. And I put this image very intentionally because I want students to understand that tax is a percentage. Another opportunity that I saw here is at the very end where it says Roman citizens earned income and paid taxes with silver coins called denarii. And for all of my Spanish speaking students, which my classroom roughly has 85 to 90% of Spanish speakers, I thought this was a great connection to that Latin word to the Spanish word for money, which is dinero. So I wanted to mention that as well. Then we move on to the turn and talk portion where students will pair up in groups of two. Imagine that you're an emperor of Rome, you want to tax a percentage. The citizens fairly, how much would you tax? So these are the three citizens that I saw in the lesson here in Eureka, right here. Just copied and pasted, I did not change anything. However, I think it would be helpful for students to have some discussion questions just to guide their thinking. What does fair mean? Does fair taxing depend on oh how how much you make? And is taxing in itself fair? Just getting them talking. I like how Eureka does have a little bit of some discussion questions here presented. So this is the launch that I'm talking about, and that launch is the intro to my lesson. So here there are some questions that you can definitely ask students. Something that I've decided to omit is this whole the symbols of percent. This I think this will be very confusing for my students. So I don't think it's necessary. And again, my rationale is this is what students are being assessed. If I'm looking at the standard, this is not part of the standard. So I want to just omit that. So then, let me change it here too. Then we'll have a brief discussion about what they discussed in their groups. I'll call on one or two pairs. So the introduction is like 2 minutes, turn and talk 5 minutes, that's 7, and then 3 minutes of discussion. So the introduction portion of this lesson will be 10 minutes. In the interest of time, I don't think it's necessary to have this introduction. In my school, we follow the workshop model, and I know that these 10 minutes do not allot for much time for the mini lesson later. So this can definitely be omitted if time does not allow. Then we go here for our objective. I will be able to calculate a percent when given a part and a whole. And I am using the next generation standards. The key question for this lesson, which is a question that I will address at the end, when given a part and the whole, what strategies can we use to determine the percent that the part represents? So this is my mini lesson. It starts off with an image of something that students should be very familiar with, which is a phone battery. What information about the cell phone battery can you determine from the picture? What information cannot yet be determined? So this will be another whole class discussion. It doesn't have to be a turn and talk, although you can definitely do that. Actually, let me change this to example 3. Even though I haven't done example 1 and 2, I call this example 3 because that's how it's seen in their student books. So I don't want to confuse them with like, oh, hey, this says it's question 3, but it's question 1, so I just keep it the same. And then there are 3 questions that go along with the image. So this represents the same battery as we see here. What percent of the battery charge does each unit of the tape diagram represent? And so we can have a discussion about how many total units are in this tape diagram, how much does each represent is the question that's being asked here. And then it keeps asking prompting questions. So this is a good opportunity to show students you can find the percent of something, the percent of a fraction, through using a tape diagram. And then now moving on, there are several of these types of questions where students have, it's like different, you see the following students estimate the number of hours. Okay, there are a few of them, but I'm only choosing to do one because, again, it's a lot of talking, a lot of teaching, and that's not what the workshop model is. We want students to get to the work, collaborate with their groups, and learn through exploration. So I've decided just to do this one. Ryan's phone lasts 10 hours. Another great question to ask is, his phone battery lasts 10 hours? What percentage is that? So they need to understand that. How many hours will Ryan's phone last when the battery remaining charge is 40%? So then we'll do that. Students will, especially those in groups that are lower leveled, will be given this. This is like the key information of this. So in order to find a percent when given a part and a whole, you can either use a diagram like a tape diagram or a double number line, or you can use equivalent ratios. The group work part. So the below grade level group will do practice, I don't know if it's called like the practice set, 1 through 7 differentiated worksheets. So this is what I was thinking. Let me show you how it looks like. For the lower level group, I'm not changing the numbers because I tried changing them and it was just going to be weird. What I am going to provide students with is a tape diagram already there, broken up, and they will have to fill in the numbers. And they will also have to answer the questions. For this, I will leave it as is for the lower level. For the approaching grade level, practice 1 through 7 with no differentiation. So they will create that tape diagram from scratch or the double number line, whatever they choose. For those students who are on grade level, questions 2 through 8, and I can show you how they look like. So 2 through 8. So we're incorporating now a longer word problem where they have to understand the context, create their tape diagram or diagram, whichever they choose, tape diagram or double number line. And I'm trying to not make it so many questions. As you can see at the very bottom, it says if you're finished, you can complete the remember questions. That's something that is new in this Eureka. They provide these questions that kind of spiral to topics they should already be familiar with. And it's kind of fun because it's low stakes. Students can just do that, practice their division here, word problem skills. After the group work, students will be given answer sheets so they can check their work. And we'll review that question that I asked at the very beginning. Like, what are some strategies that they like to use in order to find a percent? And then finally, the exit ticket. Like I mentioned, I got rid of the word in the exit ticket that says double number line to just diagram. And I'll make sure that students know. And then I just color coded some differences because these questions look very similar, but they're asking different things. The first, they want to know the percent for the new game, the percent for the snacks, and then the percent for what's remaining. So I just want students to pick up on that. And that is the lesson. The plan is for this to take 45 minutes, which is 1 period at my school. And yes, now, after all this work, I feel like I've been working on this for forever. I can go in and create my lesson plan.